This lesson is on solving logarithmic equations, and there are a couple of types of logarithmic equations we're going to discuss on different ways that we can solve. So first of all, this is like the examples that we have been doing the last couple of lessons. We just need to rearrange it back to exponential form. So if you have a single logarithm and a number that is not a logarithm, you can always rearrange it. This would be 3 to the second power equals 4x minus 7. So just rearrange using our rules of logs that we learned back in lesson 1, right here. All right. Then we just work it out. So 9 equals 4x minus 7. Add the 7 and we get 16. Divide by 4, and x is 4. All right. Another type of problem that you might see is one where each piece has its own logarithm. And so in this case, we could just cross out the logs. Now you do want to bring this over as an exponent first. But now they both have log base 5 on each side. So remember that we can now get rid of those. We know that x squared is 9. So we'd take the square root of both sides, and x would be plus or minus 3. But this is a good time for me to bring something up. Inside the logarithm always has to be positive. So x must be positive. You can't take the log of a negative number. So therefore, even though we get the square root of 9 could be positive or negative 3, only the positive 3 is an actual solution. So be careful with that. I'll show you again another example in a minute. But you can't take the log of a negative number. All right. Then we come to the kind of problem where we have a couple of logarithms with a number. We're going to treat it just like number 1. However, we need to combine the logarithms together before we do anything else. You can only have a single logarithm before you can rearrange the problem. So to combine these, it's addition. We're just going to multiply. So we have log base 4 of x plus 3 times 2 minus x equals 1. And then we can rearrange because now it's just like number 1. We'd have 4 to the first power equals x plus 3 times 2 minus x. 4 to the first power is just 4. Over here we need to distribute. Multiply all of this together. So x times 2 would be 2x. X times negative x is negative x squared. 3 times 2 is 6. 3 times negative x would be negative 3x. And then we're just going to combine like terms. So we have 4 equals 2x minus 3x would be a negative x. So negative x squared minus x plus 6. Right now, it is quadratic. And so we're going to need to move everything to one side. And usually it's easier to factor if this x squared is positive. So I'm going to move all of these values over here to the left side, which is going to change their signs because I have to add the x squared, add the x, and then subtract the 6. So 4 minus 6 would be negative 2. And there's nothing left on the right side. And now we just factor it. So x times x, 2 times 1. We need a positive 1 in the middle, so plus 2 minus 1. So x equals negative 2 and x equals 1. Now this might be one where you would consider what I said in number 2 about x has to be positive. The x inside your logarithm has to be positive. So we got a negative answer. Does that mean I need to exclude it? Well, what I have to do now is go back up here because it wasn't just an x. We can't take the log of a negative number, but if I put negative 2 in here, negative 2 plus 3 is actually positive 1. Negative 2 in here, 2 minus negative 2 would be positive 4. So this is going to be fine. So is the 1. It gives me the log of a positive number. So both of those are actually solutions. So don't get it confused that you can't have a negative answer. You just can't take the log of a negative number. All right, number 4 is very similar to number 3. Before we can rearrange this, and we are going to rearrange because it has a number over here by itself, we need to combine. And to combine these, addition becomes multiplication again. So we have log base 3 of x times x minus 6 equals 3. If this had been subtraction, we would have just made this division. So it doesn't matter how they need to be combined. Addition is multiplication, subtraction would just be division. And then once you have that single logarithm, you can rearrange it. 3 to the third power equals x times x minus 6. 3 to the third power is 27. And then we distribute over here x squared minus 6x. This time we still have a quadratic, and the x is positive where it is, so I'm going to leave it there and put the 0 on the left-hand side. And then we're going to factor. So x times x. We need to figure out what multiplies to give us 27, but also what add or subtract to give us 6. That would be 9 and 3. We need a negative 6, so negative 9 plus 3. So when we solve that, we get that x is 9 or x is negative 3. All right, so the 9 put back in here. Looks like it would work fine. The negative 3 in here, though, we would be taking the log of the negative number both here and here, and we can't do that. So we have to eliminate that. It's called an extraneous solution, an extra solution that if we can't use, we can't take the log of the negative.